Actually, guys, I always want to become Iron Man, but because I'm afraid of altitude, and that's why I changed my plan to become Batsman. Because in both the cases, you are going to become rich. So, to become a Batman, you need some gadgets, and the special gadgets of Batman is ultrasonic sensor. So guys, today we will learn how to program the ultrasonic sensor with the help of Arduino. My name is Bhushan and you're watching cloudyrathor. So before going for the programming the ultrasonic sensor, we need to know about some basic fundamentals and some small physics behind the ultrasonic sound or the ultrasonic sensor. So let's begin. So how to program ultrasonic sensor? So if you want to program the ultrasonic sensors, you need to know the fundamental or the physics of sound. Obviously, we are going to talk about sound, so we need to know what is the speed of the sound and what we can do with the sound. So this is how the ultrasonic sensor look like. We also called HC-SR04 to this sensor, and we have 4 pins along with this sensor, and these pins are VCC, trigger, echo and ground. So especially we have 2 things, that is one for transmission and one for receiving the ultrasonic sound. So how ultrasonic sensor works? So as I already told you that we have 4 pins, that is VCC, a trigger, echo and ground. So we are specially interested in trigger and echo. So where trigger means the sound which we are going to send. So we know that the speed of the sound is 344 meter per second. So as soon as we send the sound, it get back, means we get the echo of the sound, and then we will calculate it. Means that the time between sending the sound, means transmission of the sound, and receiving of the sound. So how it works? So as we know from our childhood or from our school days, that speed equals to distance upon time, and sound travel at about 344 or 343 meter per second in air. So if you want to calculate the distance, then we need to rearrange this equation as distance equals to speed into time. So now we need to find the time to calculate the distance. The only one thing we have, that is speed of the sound, and as we already know that the speed of the sound is 343 meter per second. Now one thing we need to find out is the time. So for this, to find out the time, we have this sensor. So this is two-way journey, because when I'm transmitting the sound and I will get the sounds, it's a two-way journey. So this is the two-way journey of sound transmission and receiving the sound. So we need to find the difference of transmission time and the receiving time, and we will get the time. So now as we get the time, now time to calculate the distance. Now we have a simple formula, that distance equals to time into speed, or speed into time. Now we have duration. Means the time between sending and receiving. We got the duration, and then we need to multiply this with the 343 meter per second. So here we are going to multiply duration into 0.034, and because this is a two-way tree, we will divide this entire multiplication by 2, and here we divide by 2 cause of two-way journey, and here we got the distance. And once we get the distance, then we can use this sensor in many ways. If you want to make an obstacle detector, then you can use this sensor. If you want to make a safe distance, or if you want to keep a safe distance between you and the other person, then you can also use this sensor. If you want to use this sensor for obstacle detection for drone, so that your drone can't stuck on the walls and like this, so you can also use this sensor. So today we will learn how to program it. So for coding terminology, we need to know, so the trigger pin. So the first of all, because in my previous video, as I already told you, I always try to connect this sensor directly on the board instead of using any breadboard, because sometimes we don't have breadboards, and that's why it's very difficult to connect all these things to the board using jumpers, and sometimes the jumpers are loosely coupled. So that's why I'm going to connect this sensor directly on the board. So to connect this directly on the board, I will apply one the pin numbers, that is 10, 9, 10, 11, 12 and 13 number of pin serially. So the trigger pin code is look like this, that is we are going to write low on the trigger pin for 2 microsecond delay, because we need to send something, because bat also sends something and then receives. So that's why we will send a trigger of 2 microsecond, then we will send a trigger of 10 microsecond, and then try to find out the echo what we are getting. Then the echo pin code is look like duration equals to pulse in, where we get the echo pin, we are going to initialize the echo pin high, and here we got the duration. Once we get the duration, just we need to duration into 0.0343, and the whole multiplication is divided by 2. So this is all about the programming or the coding terminology. So let's begin the coding. So to start the coding, we required an IDE. So dear all, first of all, connect the sensor on the board with the help of this diagram, and for the sake of indication, we will also connect one LED on the board. So first of all, connect your sensor on the Arduino board with the help of this diagram, and then it's time to code. So to code the ultrasonic sensor, we need to first take constant, that is constant int, and then constant int we have trigger pin, and we are going to use this like this. We are going to connect like this, like 10 for the VCC, 11 for the trigger and echo. Then echo will be on 12 and trigger will be on 11. So 11 const int echo equals to, so our echo will be on 12. So echo will be on 12. Now we need to int VCC, so our VCC will be on 10, and obviously the ground will be on G and D will be on 30. Now it's time to set up. Now okay, we again require 2 variable for calculating duration and distance. Now it's time to set up. I'm going to set up all these pins. So first of all, I will write serial.begin to check the message on the console or the message on the monitor. I will select the baud rate of 115200. Now pin mode. So we have pin mode for VCC output. Then I will copy this code. Okay, right. Now trigger pin, and then echo, and then GND. So as we already discussed, our echo pin going to become input, because whatever we are going to send, that is trigger, will come back and we will receive on echo. So our echo pin must be input. Now setup is ready. Okay, one more things we require, that is for LED. So LED, so I will connect LED on 3 and 4. Okay, so LED LED VCC, LED VC. Oh, okay, LED will be on 2, and INT LED GND on 4. And here I need to again initialize, that is LED output in output mode, and also LED underscore GND also on output. Now we are initialized. Now it's time to configure the pins. So I'm going to configure the pin number, that is digital write. So I need to write the pin number which is for VCC or high. Then I will copy and paste. Okay, so this is my VCC and GND for my sensor. So GND obviously become low, and here for LED, okay, LED will be high. Okay, we will make this pin number according to our application. So I'll just low LED underscore GND, and I'll keep its status low. Okay, and then as per the distance we will decide whether LED will go for high status or low status. Okay, now to calculate the distance, so here in loop I will write digital write trigger from so I need to send one sound, the ultrasonic sound, digital with some delay, that is delay seconds, delay microseconds of 2 microsecond. Then again I need to send one pulse, ultrasonic pulse for digital write trigger, and I will make it high, and again for 10 microsecond it will going like beep beep. Okay, so then again we need to write digital. Okay, instead of typing it I will just copy and paste to minimize the errors. So again I will make it low, so keep it low. Okay, so this is our trigger. Now once we send the trigger, now it's time to check the echo, that is we are going to calculate duration. So it's a duration equals to pulse in its inbuilt function, and here we need to give two arguments. So first one is echo, that is high. And now once we get the duration, now it's time to calculate the distance. So distance equals to duration, that is time into speed. So 0.3433 0.343, and the whole multiplication is divided by 2. Now we calculate the distance. Now it's time to print this distance on the serial monitor. So it's a serial dot print. Now write down distance equals to, okay, serial dot println, and now distance. Now we got the distance with a delay of say 100 milliseconds. Now our program is ready. Now it's time to upload the program. So I will connect So now select the port, then give the permission. Now upload it. So before uploading we need to save it. Okay, save the same. Now check the serial monitor. Now our connection is look like so guys, our connection is look like this. So here we connect all these pins. So here we connect all these pins, that is on 11, 10, 11, 12 and 13, and here we place the LED. So now it's time to program for the LED, and once we program for the LED, then we will go for the check. Okay, now here we are getting the distance. So as soon as I keep my hands near to the sensor, so it will show the distance of the obstacle. So here you can see the distance of the obstacle. So here, so right now it's checking fine, it's working fine. Now it's time to check for the, it's time to write the code for the LED. Now let's begin. Now I want to check if distance is less than or equals to, for say 6 centimeter, then it need to say println keep safe distance. Otherwise it need to say serial dot println you are a good guy. Okay, now it's time to again upload the code. Okay, we need to write the code for LED also. So So dear all, we program the same, that is, as soon as the distance is less than or equals to 6 centimeter, so it will glow the LED and say keep safe distance, and if it is not, then it will say you are a good guy, and then it will off the LED. So let's check how it works. And once you upload the program, here you can see, so here you are a good guy, and as soon as, so here keep the safe distance, the distance is 5.59, and as soon as I keep the hands far from the sensor, it shows that distance is more than 6 centimeter, and as soon as I keep the hands near to the sensor, it says keep safe distance. So guys, this is how we program the ultrasonic sensor, and we can use this sensor in many projects. Just like in our next video, I will show you how to use this ultrasonic sensor to make a contactless sanitizer dispenser with the help of servo. So if you want to learn about how to program the servo, you can refer this video, which is on the right top bottom, and then with the help of this video you can make the next project, that is a contactless hand sanitizer dispenser. So guys, this is all for the day. Next time we will see you with some new stuff. Till then, bye bye, and don't forget to subscribe and like and share.